Hi friends, my name is Sunil Binkam and welcome to Sunny Tech Explore. Today we are going to talk about Kubernetes from a beginner's perspective. Before getting into the concepts, let us understand some terminology. Kubernetes is a portable, extensible and open source platform for managing containerized workloads and services. And Kubernetes is portable because it can be implemented on any public cloud like in Azure, AWS and Google, and even if you have a private cloud you can implement the cluster, and in local data center you can implement the Kubernetes cluster, or even in your local machine from development perspective you can install Kubernetes cluster via Minikube. So it's a portable platform, and also Kubernetes is an extensible platform and it provides plugin mechanism and add-on mechanism and other configuration sources to extend your deployment and solution. And it is an open source platform, and it is initially created by Google, but later it is open sourced, and currently cloud native computing foundation is actually taking care of Kubernetes versioning and its life cycle. And here we can see the containerized word is highlighted in yellow because that's the important thing here, and we have the definition of containerized application and container below. But how can we understand? We can read the definition, but how can we understand? So for example, if I have a Spring Boot application and that is an application, so to make it as a containerized application I have to add a file called docker file, and in that when I provide the definition to make it to build it as a container, then it becomes a containerized application. So my Spring Boot application, when it comprises of a docker file, and when I build a container out of it, it will become a containerized application. So that is an application that has been packaged together with its dependencies and configuration into a container. Okay, now what is a container? Container is a lightweight standalone executable software package that includes everything needed, almost similar to that, but it runs. The container runs, like for example, my Spring Boot thing docker image is already ready now. It is a containerized application. When I start that, it will become a container. My Spring Boot application container, maybe hello world container, right? So it becomes that container. And now just to compare so that how this Kubernetes and Docker, they are all related, but how can we how can they work together? To understand that, let us compare with the Spring Boot application. So I come from Java background, that's why I'm comparing with Spring Boot application, but this similar analogy can be applied for any other application. For example, we have a Spring Boot application, and Spring Boot application itself is a self-sufficient executable jar. So once you create a Spring Boot project and once you build it, it will create you a jar file, and that jar file you can run anywhere that where the supported Java runtime engine is there. Similarly, when you create a containerized application, it can run wherever you have that container runtime. Maybe a Docker is one example of a container runtime. We have container D also as a container runtime. And now if you think about a large deployment, maybe you have an Angular application or Spring Boot application, maybe for an e-commerce scenario, you have multiple applications working together. So in that kind of a scenario, your Kubernetes will come into handy so that you can manage the deployment and scalability aspects of your solution. So that's how we define here when multiple applications need to interact to achieve a business outcome. So that business outcome is any like for a e-commerce, that e-commerce is the business outcome, or maybe our IRCTC is there. So IRCTC business is to help us to create tickets and manage that reservation. So that's the business outcome. So multiple applications were working together to provide that business outcome, and a higher level management component is essential when you have all these components working together, so that we can in a centralized way we can manage the deployment and configuration and also the scaling aspects of it. So now Kubernetes comes into picture for a containerized deployments. It will provide that higher level management, and it helps in the deployment, and it helps in the configuration, and it also helps in scaling automatically based on some thresholds that we define. Maybe if the number of requests increased more than a threshold, then it will either add a new replica in the add a new replica to manage the load. So those things we are not going to cover here, but how it can be compared, like if you have a Spring Boot application or a .NET application or any web application, so you can think like that application is actually running on a runtime, corresponding runtime. In the same way, your containerized application is running on a Docker environment. So with that, let us move forward. Yeah, here also we just provided a kind of a scenario to compare, like we have an Angular application as a front end and a Spring Boot application as a back end and a Postgres database to store our data, and this is a solution, right? This is a business solution, and now in this scenario we can deploy 3 separate containers, one for Angular, one for Spring Boot, and one for PostgreSQL. Okay, and this Kubernetes can help us when the traffic fluctuates. It can dynamically add or remove containers. Okay, now so let us try to look at from a high level picture view. So obviously picture conveys more clearly than multiple words. So this is a very high level, and I didn't depict any internal details of what comprises of a control plane, all those things. It's a very high level bird's eye view kind of a thing. So if you look at this diagram, you have a control plane. It is like management. Before that, even we divided this into 3 layers. One is the management layer, the deployment layer, and the end users who interact with this, right? So in the management layer comes the control plane, and this is responsible for managing and orchestrating the containerized applications. So that's how it will create these pods, or we will see what are pods and the applications inside this deployment area. And these nodes here in the deployment area are the hosts for the pods and the container runtime that runs the applications that we package as this containerized applications. And here load balancer, it distributes the incoming traffic to pods, like these end users are accessing our application, then these requests are actually going through various nodes or the pods that inside that via the load balancer. First let us get inside the control plane. So what is a control plane? So control plane is a management component. It comprises of 4 key components. One is etcd. It's a kind of you can think of it as a data store about the cluster. Maybe for example, if you go back to the analogy that we had previously for Spring Boot application or any other application, now I have a IRC, maybe for example IRCTC application is there. So all the ticket data, or booking data, and our account data, our personal profile data, every data is sitting on some database. So for Kubernetes, for all the containers it is creating, all the pods it has, all the nodes it has, the cluster has multiple nodes and all these things, all the information about these deployments and all these things will be available in the etcd. We can think of in that way. So it's a highly available key value store for all the cluster related data. And controller manager is like, you know, this is responsible to monitor and manage, sorry, for various the nodes or whatever that no, jobs or endpoint. For example, we have a node, uh, almost the CPU or memory is almost, up to 98 80% something like that. So now this controller manager is the component that knows about it via the kube-api server. Okay. And the scheduler is responsible for when you create a pod or when you are deploying. The scheduler actually schedules the up bringing these containers up. That means any application that is not running or any application that you want to deploy is taken care by scheduler to actually deploy and, you know, make it up in the container. And kube-api server is a kind of a front facing between the control plane and the other applications deployed in the nodes. Okay. So via this REST API, the inter-component communication happens within Kubernetes. Next. So here we'll see the structure of a node. Previously we saw control plane, and via this control plane is connecting to the node. Here how a node looks like. So it has these elements: kubeproxy, kubelet, and container runtime. So here, even though we represented them as a layered fashion, it is not actually layered kind of a thing. So a kubeproxy and kubelet container runtime are one per node. That's why we mentioned one like this. And kubeproxy and kubelet, they are they will work for as a network proxy. Kubeproxy is a network proxy, and the kubelet is the agent to interact with our control plane. But container runtime is the one which actually provides the runtime to build or to bring our pods up and run our containerized applications. Okay. So this container runtime, as we previously also talked about, it's a I mean, Docker is an example, container is an example, CRIO is an example. Like that, multiple container runtimes are there. That's why throughout this presentation, we didn't specify Docker container as such, but we just mentioned container. Okay. And here these are the pods. You can think like multiple pods can be there on one node. Okay, these pods are the smallest deployable units that can be created and managed in Kubernetes. To get a proper example, in our hypothetical case, we have a Angular application, Spring Boot application, and a PostgreSQL application, right? So in that scenario, now we have one node, one VM or a physical machine, where we have in this example container runtime, we used Docker as an example. In that we have Angular pod, a Spring Boot pod, and a PostgreSQL pod. That's how these things will be or can be visualized. And now with that particular thing, there is a problem. Okay, so that problem is by default containers are ephemeral. That means they will have a short-lived runtime or a short-lived time. So that means if a pod restarts, whatever data that locally stored will be wiped off. So a new instance of that container is actually created. So it cannot persist. So in that case, if you are planning to use any database, you cannot actually store that data, right? Whenever the PostgreSQL pod restarts, it will go off, the data will be wiped off. But how can we solve this problem? For that, actually there is a concept called persistent volume. So what we'll do is, we will create, or we will in a general deployment scenarios, we will attach a data disk to the VM, not the VM in the cluster. In local scenarios, development scenarios, you can use any folder path. Okay, so how this PV and PVC are persistent volume and persistent volume claim. How can we understand these things? So persistent volume is the physical storage that you are attaching to a cluster. For example, in this diagram we have a data disk that is mounted on the VM. Okay, so now this data disk becomes our persistent volume. Now our pod, maybe in our example Postgres is there, maybe for example if this PV is of 500 or maybe a 256 GB data disk, and now in the Postgres we wanted a 10 GB claim. Okay, 10 GB data only we wanted. So now in our pod deployment specification we will say, okay, our Postgres pod is requiring, or it requires 10 GB data. So now that 10 GB is a claim that this pod is making on the persistent volume. That is the difference between PV and PVC. So maybe just to give you an analogy and an example, if you consider a group insurance any company buys, right, for the employees, that group insurance is like the PV, persistent volume, and each time whenever a employee claims it, so that is the PVC. Just a kind of a conceptual understanding. And now let us put these things together. So now we have the control plane which manages various nodes. This time what we did, we split the Angular pod and Spring Boot pod, because the data whatever that they are handling, even if they are restarting, we don't mind because they are all stateless. Okay, and container runtime. So these are all normal node structure. Now our PostgreSQL pod is actually interacting with this PV via PVC. That means PVC claim, PV claim, right? So in this way, what can we achieve is, this is a different node, this is a different node. Now along with PostgreSQL, if you want to have any other pod for new application that you are going to deploy in this runtime, any persistence requirement pod can be deployed in this particular node. Okay, and any non-persistent requirement pod can be deployed here. Now if you want to do the same thing for a local development, right? So in the local development you are not going to add one more disk, something like that, but you can use any folder on your local machine and it serves the purpose. So in that case, maybe for example you have a Rancher desktop, a Docker desktop, and now you will create one folder and you will map that as a PV. In this tutorial or in this video we are not going to do anything hands-on to configure this PV and all those things, but we are going to make a different video, that is part 2, to explain or to do all these things whatever we talked about today, like the Angular pod and the Spring Boot pod and the PostgreSQL pod, as a practical session that we will do in the next video. And now in this video, what we learned is what is a container, what is a Kubernetes, what is control plane, and container runtime and nodes and all those things. And we journeyed through from the like initial concepts, like high level what is the control plane and a node and all those things, and we journeyed through like what are the components of control plane and what is the responsibility of them, and how a node in general looks like and what are the key components. And if you want to understand from a real world example, and how can we think or visualize from an Angular or a Spring Boot or a PostgreSQL perspective, and in that case we also understood that any data persistent required pods cannot be deployed just like a pod, but it requires a special configuration of this persistent volume and persistent volume claim, and then we visualized in real world how it would be, so that we have multiple nodes, specific nodes with persistent volume mounted, and the other nodes which will not have that mounted. But one key component work, one key point is, even though this particular PV is mounted on this one node, okay, this is actually it can be used by even this pod also. That means even this PostgreSQL pod, even if it is deployed here, only thing is we need to map this PV and mount as a path, so that this PVC can be claimed by even Angular pod if required, Spring Boot pod if required. Okay, so maybe for example you have a file upload scenario. Now your Angular application is providing you a file upload user interface, and your Spring Boot has this file upload management, and you wanted to store temporarily in a location. So obviously because your Spring Boot is a pod, it cannot store anything on in its local, because when the pod restarts it will lose that file. So it can use this PV and PVC via PVC, and then it can store there, so that even if the Spring Boot pod restarts, it can have the access to the file previously it saved. So PV and PVC, we will attach it to a node because that is a storage or a disk, but because it becomes a PV from a Kubernetes perspective, it is available for the whole cluster. Okay, that's what we'll cover in this video. For next, in the next video we will do a hands-on deployment of this Angular and Spring Boot and PostgreSQL, and in that video we'll only focus on the deployment only, not the development part of the applications. And thank you, and if you like this video, please subscribe and share it with your friends. Thank you very much.